Good day, viewers. Welcome to Sufficient Grace Math class. In today's tutorial, we are going to be treating laws of indices. Before we go into the laws of indices, what is indices itself? Indices is the power or exponent which is raised to a number or a variable. Then we need to know that the plural form of index is indices. Generally, if n is a positive integer, then a raised to power n means a times a times a up to n times, where a occurs n times. Before we consider some laws of indices, for more clarification, we need to know this. If we have 2 raised to power 3, 2 raised to power 3, 3 here is called power or index. While this 2 is called base. Also, 2 raised to power 3 means 2 times 2 times 2. That is 2 multiply itself 3 times, which gives us 8. Let's now consider the following laws of indices. Number 1, a raised to power m times a raised to power n is equal to a raised to power m plus n. In this law of indices, we will see that we are having the same base, which is base a. Inasmuch we are having the same base with different or same power, and they are multiplying each other, what we just need to do is to remain a base, which is base a. We remain a base, which is base a, then add up their power. Example of this: 2 raised to power 3 times 2 raised to power 2 is equal to 2 raised to power 3 plus 2. We can see that we are having the same base, which is base 2, with different power, and they are multiplying each other. What we just need to do here is to remain a base and add up their power. Then we have 2 raised to power 3 plus 2, which is equal to 2 raised to power 5, which gives us 32. Number 2. A raised to power m divided by a raised to power n is equal to a raised to power m minus n. In this law of indices, we will also see that we are having the same base, which is base a. Inasmuch they are having the same base with different or same power, and they are dividing each other, what we just need to do is to remain a base, then subtract their power. We remain a base, then we subtract their power. Example of this: 2 raised to power 5 divided by 2 raised to power 3 is equal to, inasmuch we are having the same base with different power and they are dividing each other, what we just need to do is to remain a base, which is base 2, then subtract their power. Then we have 2 raised to power 5 minus 3 gives us 2 raised to power 2, which gives us 4. Number 3. A raised to power m into n is equal to a raised to power m n. Whenever we see this type of law of indices, what we just need to do is to multiply their power by each other. We multiply their power by each other, then we have a raised to power m n. Example of this: 2 raised to power 5 raised into 2. In this case, we are going to multiply their power by each other, 5 and 2. Then we have 2 raised to power 5 times 2, which gives us 2 raised to power 10. And 2 raised to power 10 is equal to 1024. Number 4. A raised to power minus n is equal to 1 whole over a raised to power n. In this fourth law of indices, a raised to power minus n, what we just need to do here is to find the reciprocal of this a, which is 1 over a, then raise it to power positive n. Find the reciprocal of this a, which is 1 over a, then change this negative power to positive power. Example of this: 2 raised to power minus 3 is equal to, we find the reciprocal of these two, which gives us 1 all over 2. Then change this negative power to positive power. Then we have 1 whole over 2 raised to power 3 is 8. Number 5. A raised to power 1 over n is equal to n root a. A raised to power 1 over n is equal to n root a, and n must not be equal to 0 for this case to be true. Example of this: simplify 25 raised to power 1 over 2. 25 raised to power 1 over 2 is equal to square root of 25, which is equal to 5. This 1 over 2 makes it to be square root of 25. We are having square root here because this is 1 over 2. These 2 here makes it to be square root. Another example of this: simplify 8 raised to power 1 over 3. 8 raised to power 1 over 3. 8 raised to power 1 over 3 is equal to cube root of 8. This 1 over 3 makes it to be cube root of 8. This 3 here makes it to be cube root of 8. That is, if we are having 1 over 4, we are going to be having 4th root of 8. But this one is 1 over 3. Then we'll be having cube root of 8, which is equal to 2. Number 6. A raised to power m over n is equal to n root of a raised to power m, or n root of a, everything raised to power m. Example of this: simplify 16 raised to power 3 over 4. 16 raised to power 3 over 4. 16 raised to power 3 over 4 is equal to, by using this, we have 4th root of 16 raised to power 3 rather, which is equal to 4th root of 16 raised to power 3 is 4096, and 4th root of 4096 is 8. Using this, it gives us 4th root of 16 everything raised to power 3. In the bracket, we are having 4th root of 16. 4th root of 16 is 2, then raised to power 3. 2 raised to power 3 is equal to 8. You can see that we are still deriving the same answer. Number 7. A raised to power 0 is equal to 1. In this law of indices, what this law of indices is telling us is that any non-zero number raised to power 0 is equal to 1. I repeat, any non-zero number raised to power 0 is equal to 1. Example of this: 10 raised to power 0 is equal to 1. 20 raised to power 0 is equal to 1. 100 raised to power 0 is equal to 1. 1000 raised to power 0 is equal to 1. And this is all what I have for you today. Thanks for watching. Please don't forget to like, share, comment, and subscribe to my YouTube channel for more exciting video. Thanks.